Right, good afternoon, everyone. Welcome to the final edition of the 102 stream for this year's GSE annual virtual conference. This session is Improving Business Agility with Data Virtualization, being presented to us by Robin Anderson from Rocket Software. Robin is happy for me to relay questions throughout the presentation. So if you've got any questions, pop them in the chat. Or I can unmute you, and feel free to obviously ask the questions where you feel relevant, and I will cascade them to Robin. Also, feedback-wise, there will be, I think there's a link on the GSC website to provide some feedback after, which I'm sure Robin would welcome. So yeah, Robin, over to you if you'd like to introduce yourself and make a start. And again, thanks for joining us today, everyone. Thanks, Robin.
Thanks, Chris. I wanted to do a brief introduction of myself and my background before we get started. Don't worry, it'll be very brief. But basically, the majority of my career has been spent in product development and product management as the business leader, working side by side, hand in hand with the engineering team. From starting with myself, conducting new market analysis, to actually working on the requirements and features of the system, delivery of the system, and primarily focusing on large-scale product development initiatives. So I wanted to tell you a little bit about myself. I'm currently the product manager for data virtualization for Rocket Software. So I'm really excited to share information about data virtualization with you. Specifically today, we're going to be focusing on business agility as it relates to data virtualization, improving business agility. So if we look at the agenda for today, I'll be covering the importance of business agility to enable business solutions, the challenges and obstacles we see with traditional technology and accessing mainframe data, how data virtualization can help to address these challenges, which is really exciting, the key components of a data virtualization solution when you're looking for a solution that is really going to help your business, your operations, your technology. And then the bottom line, what's the value that a data virtualization solution provides to organizations? Before we dive into the detail, I'd like to hear from each of you. Chris can unmute you, or you can put it in chat. I'm curious if you have little or no experience with data virtualization. There's going to be three options. That's the first option. You're aware of data virtualization or have some experience, or you've actually utilized data virtualization. So if you could just take a moment and put that in chat, or raise your hand if you want Chris to call on you. That will help us understand where you are in terms of your knowledge of data virtualization. While you're doing that, I'll talk a little bit about what is business agility. What does that really mean? Because everyone can have their own connotations of what is meant or intended by business agility. For our purposes in today's meeting, it's really the ability for an organization to compete and to thrive in today's digital age by being able to respond quickly to market changes, emerging opportunities, with business solutions that are innovative and digitally enabled. It's, as we all know, it's very challenging today to keep up, and also critical. So what are some of the environmental factors related to business agility? Talked about the point of how essential it is, especially in this age of constant change. Data, and I'm going to be showing some stats on this in a moment, is growing. It's being stored longer. It's just getting bigger and bigger and bigger. And these systems remain a mission critical platform that drives data growth, and we'll be looking at that data as well. So modern solutions, which is what data virtualization helps to achieve, are needed to help address these challenges. Let's take a look at the landscape of the data right now. So from a enterprise perspective, these systems generate 75% of all enterprise data. And if you look specifically at operational data for banks, retailers, large enterprises, from a global perspective, it's in that same range. It's 70%. So that's a lot of reliance on mainframe data. Mention the fact that it's 75% of data. One of the key things I'll point out here is just the criticality and the size and scope and magnitude of how mainframe data affects consumer commerce. I mean, look at just some of these key items I'll point out is 30 billion transactions per day, $3 trillion worth of daily commerce that's exercised. And I think credit cards, the ubiquitous thing that we all have, that we all use, 90% of all credit card transactions come from mainframe data. So very, very important. So let's talk a little bit about the challenges and the obstacles of traditional technology. Because many enterprises, as from a mainframe perspective, rely on the mainframe, and there are challenges with getting the data in a timely manner from the mainframe to use it as needed. Typically in organizations, that data is segregated by business unit, by format or platform. It's disparate. Older architectures, depending upon the enterprise, can't handle data volume, velocity, variety, and so that valuable business data is locked away in secure transactional systems. So how do we get to that? How do we make it available so that we can be more agile? Another component supporting that is that traditional data integration is inadequate. From an ETL perspective, it's expensive and it produces latency when we use some of those traditional ETL methods. It creates, when we're looking at moving data, risk to data security. We see data inconsistency and rigidity, which limits business agility. And as I mentioned, the high cost and latency. So getting to the data in those traditional methods is not viable anymore if we want to be agile. So how can data virtualization help to address these challenges, which is the crux of why we're here today? Data virtualization creates virtualized views, might be self-evident, and integrated views of disparate data in memory for immediate read and write access, so you don't have to wait to move the data or hold the data in integrated views in an enterprise data warehouse. What data virtualization provides, which really helps get to that modernization and agility, is a data services layer to integrate the data and content on demand from those various sources in real time. This next one, which is crucial, is it provides a layer of abstraction shielding developers from the unique data implementation. So it helps to address that skill gap that exists today in the market in terms of having to know legacy systems or not. This addresses that. It provides a metadata catalog to keep track of the data, the location, availability, and state. It's all part of the data virtualization solution. Supports transactions that write back to the original data sources, regardless of their location. And it doesn't mandate a particular API or a particular schema. It supports many-to-many. So these are the primary components of a data virtualization solution. If we look at use cases for data virtualization, and I will preface this with, it's very important when you start on your data virtualization journey to be clear on what your use cases are. what can happen is an organization doesn't specifically define where are we going to start in terms of what we want to address from a data virtualization perspective, and it ends up resulting in scope creep, inability to really test out how it's working in a particular situation. So I can't overemphasize the importance of being clear on your use cases. There's kind of three primary areas of use case. One is modernization. So looking at how you can deliver those modern systems of engagement. So for example, being able to standardize your APIs, across different data access points. That's one area. Another one is around analytics. One of the things data virtualization is really powerful about is providing immediate insight into customer or business situations, because it's getting that data where it needs to be to look at those real-time analytics, make decisions as quickly as possible. And then the other area is reducing the cost and complexity of accessing that mainframe data, so optimizing that data access. Those are the general categories that use cases fall within. And to go back to my point, it's very important that you understand your use cases, and it's typically going to be an iterative process, right? Where you start and then you will build on that over time. Now let's talk about the DV solution itself. Data virtualization needs to provide flexible options to access the data. Remember, the data is remaining on the mainframe. High volume data movement is very important, especially as we're looking at data analytics, decision making, payment processing as an example, and then data ingestion, the ability to consume off-host data as well. Another component is that many-to-many connectivity that we talked about that supports modern APIs, REST, HTTP, SOAP, SQL, and supports a broad range of data sources, mainframe, distributed, operational, messaging. As we talked about, it's bringing those disparate data sources together. And we hadn't touched on this yet, except for the fact that data virtualization can help from a cost savings perspective. And it does reduce, if you have the right solution, mainframe TCO, which uses a specialty zip engine to eliminate up to 99% of that integration processing. One of the other areas that I want to touch on is hybrid cloud architectures. This is something that I've recently pulled into the deck because data virtualization is also very helpful because it accelerates data movement and it enables large data pools as well. And in addition, when you think about hybrid cloud architectures and the engineering and technical team members that are working on those architectures, they're not going to be accustomed to or skilled at, and there's going to be a skill gap, right, in how to access that necessary legacy information. So I added a slide about how data virtualization solutions can help as it relates to hybrid cloud, because they can load large amounts of mainframe data into Hadoop, data warehouses, cloud data repositories, and you can see in this illustration some of the components that come into play. One of the things that a good data virtualization solution will do is have MapReduce parallelism to really accelerate those data pulls from the mainframe data. Seamless integration with Scoop for high performance loads into Hadoop. And again, enhancing that existing data movement architecture. I'm going to pause here for a moment, Chris. I don't know if you have any questions that have come across yet, or if there are areas that people would like to talk more about before we move on.
There's no questions in the chat at the moment, but I had one because this is quite a new kind of thing for me. And is speed layer the same thing as, is that data virtualization? Have you heard of speed layer before?
I have not heard of that before. I will have to look into
Yeah,
that.
it's like a
What is
cached,
that?
it's like a cached layer of data that draws from like obviously an original place, which is just basically easier to grab from. And I just was wondering if it's the same kind of concept as this.
Yeah, I am not sure. I will have to look into that, and I'll follow up with you on that.
Yeah, thank you. I really
Yeah.
appreciate that. Yeah.
Yeah. Any of the participants have any feedback on that? Feel free to chime in. All right. Next, and this is kind of wrapping up the discussion, kind of bringing it all together, and that is kind of what is the value, kind of so what? I mean, we've talked about the things that a data virtualization solution provides, and we talked about the components, and some of them may seem to be self-evident, but kind of bringing it back up, abstracting it a bit. The bottom line, one component is any data for any application makes it really powerful, right? And here you see an example of some of the data types of sources that can be accessed, and it can be a non-relational or relational format, doesn't matter. So it needs to be simple, getting transactional access, right, without having to physically move the data from the mainframe. Because as we all know, there are challenges and risks related to physically moving the data. And then as we talked about, there are latency concerns and cost concerns as well. The next component is needs to be open to all application. It really, this is where the modernization piece comes in. Modern APIs that are enabling access, insulating your developers and others from having to know some of the legacy ways of doing things, so they can use more contemporary methods that they are familiar with. And this will continue to evolve as new languages, etc., come out as well. Secure, avoid the risk by reducing the movement off of Z systems, as I talked about a minute ago. Needs to be fast, exploiting Z architecture. We talked about parallelism, and in-memory processing, and cost effective. That 99% of zip offload is really helps from a cost perspective. Now I'm going to shift for a minute into from a business perspective, right? I mean, most enterprises and organizations are going to require some sort of a business justification or a business case for proceeding with data virtualization. And here again, the use case is paramount, and your iterative plan to achieving kind of what your end goals are from a data virtualization perspective. So I want to wrap up today with the real bottom line from a cost, financial, why it benefits the business perspective. And I'll go through each of these, but it needs to be tailored to your enterprise and your organization in terms of the specific business case. That's why I didn't put a business case example up here, because it depends, but it is doable to come up with a solid business case, financial justification for data virtualization. And here are some of the areas that can be used to do that. The first one is addressing that growing skills gap for legacy data sources. There are real costs associated with whether it's recruiting new employees, right, to your technology and engineering organizations, or the organization that you have being able to take advantage of them to modernize your applications. Reducing the cost and latency of moving data off the mainframe. That's, these are all real benefits that are tangible. Gaining insight from data sources not previously available. So in that example, there might be a data source that is not accessible today, that with data virtualization, and we talked about some of the ways in which it can be made available, standardizing APIs, but now you can bring data in so you're making better analytics decisions and getting a better view of where problems might be, whether it's from a consumer perspective or from a financial perspective. Talked about standardizing the application logic for data access. There's real cost savings associated with that as well. And then some of the biggest wins related to data virtualization are accelerating time to market. And there are ways in which you can calculate what that means as well, how you can bring new products, new features to general availability to generate revenue by accelerating that time to market. And then you're freeing up resources to work on more things as well. Driving that digital transformation, again, associated with modernization. And then as new things are coming up, right, in our landscape, an example is enabling that data integration with hybrid clouds architectures. So the bottom line is data virtualization, in addition to just, making things better, it has real tangible benefit to your organization and will make it better. So Chris, that's all I have for today.
That's brilliant. Yeah, thank you, Robin. Yeah, no questions at the moment, but we'll give it a minute to see if any come in. But yes, please do have a look into SpeedLayer and let me know if that's a solution that we're using, which is considered data virtualization, because yeah, it sounds very similar to what we're doing at Nationwide Building Society. So.
Yeah, I'll follow back up with you on that. It's always good to hear about other capabilities, whether they might augment or maybe they don't meet all of the same capabilities, but yeah, I will look into that.
Yeah, it's not something I'm working on, but I definitely keep hearing about it, and I hear things like Kafka and MongoDB. I just keep hearing about this cached layer that we're having to make getting to the data easier.
For Kafka and MongoDB, typically data virtualization solutions will work with those sorts of capabilities.
And maybe SpeedLayer is what we're calling it. Maybe that's something that's
I don't know. I'm looking forward to I'm looking forward to looking into it. And if anyone has any questions or additional information that they want to discuss or collaborate with, I'm happy to do that post session as well. Just let me know.
Fantastic. So yeah, get in contact with Robin if you have any questions that you can think of, and please feel free to submit some feedback as well for Robin for today's session. But yeah, we'll wrap it up then, and thank you so much, Robin, for presenting for us, and thank you everybody for joining, yeah, I think we'll leave it there then. But yeah, I'll stay in touch, Robin, and we'll catch up about SpeedLayer.
Sounds great. Thank you. Thanks everyone for your time.
Thanks everyone. Bye.
Bye.